Hey guys, this is your first video on solving absolute value inequalities. We've already solved absolute value equations and we've already solved compound inequalities. And we really put those two concepts together to solve absolute value inequalities. And you will see these on the Algebra 2 in the course exam at the end of the year, so it's really important that you learn this. Our learning target is I can solve an absolute value inequality. Let's go. So you should remember the steps that I gave you when we solved absolute value equations. Step 1, we have to isolate the absolute value bars. In step 2, we have to make two problems where we're changing the sign after the equal sign in the second problem. Step 3, we have to solve. Step 4, we check. And step 5, we write our answer in step builder notation. So let's just review what we've already learned. So in this problem, we have an absolute value equation. The first thing we'll have to do is isolate the absolute value bars. So we would have to subtract 3 from both sides and then divide by 2. So when we subtract 3 from both sides and then divide by 2, we get this problem, absolute value of x plus 9, where the absolute value bars are now isolated, is equal to 2. Next, we make two problems. Remember when we make these two problems that in the first one we just drop the absolute value bars and keep all the signs the same. And in the second one we change the signs of everything that comes after the equal sign. Now we solve each of these two equations. So subtracting 9, we get x is equal to negative 7. Subtracting 9 again, we get x is equal to negative 11. And remember, we've got these two possible solutions. We should substitute them into the original problem in place of this x in order to make sure that these are true for the equation. So if I put in a negative 7 here, that would evaluate to be positive 2 multiplied by 2 is 4 plus 3 is 7. So I know that negative 7 is a true solution. And if I substitute in a negative 11 here plus 9, that would be negative 2. Absolute value of that makes 2 times 2 is 4 plus 3 is 7. So both of these are true or make the equation true. So both of these solutions work. Our set builder notation would be x such that x equals negative 7 or negative 11. This problem is similar, but this time we have an absolute value inequality. And you should notice that the first step, isolating the bars, is already done for us. We don't have to worry about isolating because the absolute value is all alone here on the left-hand side. So we are ready to make our two problems, but there's something you need to know when you're making the two problems. A less than symbol is going to indicate that this is an and compound inequality. And a greater than symbol would indicate that it's an or compound inequality. So less than means and, greater than means or. This is a less than problem, so let's go ahead and write our compound inequality. So for our first one, we just drop the bars. 2x minus 1 is less than 5. We use the word and because this was a less than symbol. For our second inequality, we write 2x minus 1, and then we're going to flip the inequality, make it greater than, and change the sign afterwards. So we flip the inequality and change the signs after it in the second one. Now solve each of these. So when I solve these, I find that x is less than 3 and x is greater than negative 2. The directions said to solve and graph the solution. So let's come up with the number lines for this. So looking at our number lines, our first inequality says x is less than 3. So we'll use an open point at 3 and we'll shade everything that is less than 3. So that's left. And our second inequality says x is greater than negative 2. So we'll use an open point at negative 2 and shade everything right of negative 2 because right is the greater direction. And since this is an and compound inequality, we are looking for the intersection or the overlap of these two for our overall solution. So the overlap or the intersection will be all the numbers that fall in between -2 and 3. So this is the graph of the solution. In set builder notation, we could say x such that -2 is less than x is less than 3. Or we could say it this way, x such that x is less than 3 and x is greater than -2. And we could also express our answer as an interval, open interval, so we use a curvy bracket, starting with -2, going all the way up to +3, open interval. So if we look at our second example, absolute value of 3x minus 4 is less than or equal to 8. So we should see again that we already have our absolute value isolated, so that step is done. Now we're ready to make our two problems, and since this is a less than inequality statement, we're going to separate the problems with the word and. Notice that in the first problem we just dropped the bars, and in the second problem we flip the inequality symbol and we change the sign of 8 to -8. Now let's just go ahead and solve each of these. Pause and go ahead and try solving on your own. So I found that x is less than or equal to +4 and x is greater than or equal to -4/3. When we're talking about an and compound inequality, we're looking for the overlap here. Or we could even write this as x being less than or equal to 4, but also it's bigger than -4/3. So you could write it that -4/3 is less than or equal to x is less than or equal to 4. The graph of this solution is going to be on a number line. We could say that 0 is here, here is 4. What is -4/3? Well, that 3 goes into 4 1 1/3 times, so it's -1 and 1/3. So it's about here. And +4 was here. So our solution includes all the numbers in between -4/3 and 4, including -4/3 and 4. And of course we could express this with an interval using interval notation, square bracket, -4/3 all the way up to +4, including both of those boundaries. In example 3, our absolute value bars are isolated, but if you'll look, the symbol is different. The symbol this time is a greater than symbol instead of less than. So this one's ready to break apart into two problems, but this time instead of using the word and, we will use the word or because the symbol was greater than. Okay, so here's our two problems set up. Notice that the first one just drops the bars, keeps the same numbers. 5x plus 10 is greater than 15. Or, because we had a greater than symbol, 5x plus 10 is less than. We flip that symbol around and we change the signs after that. So -15. Now, pause and go ahead and solve each of these and then play again to see if you got the same answers as me. So pause now. Ta-da! So let's see if you got the same thing as me. X is greater than 1 or x is less than -5. If we're asked to put this maybe in set builder notation, we would write that as x such that x is less than -5 or x is greater than 1. And I put it in that order just because I like to put the smaller numbers first, and -5 was smaller than 1. On a number line, we know that or just means the union of the two answers. So if this is 0, here would be -5, and here would be 1. Everything that is greater than 1, we're going to get an open point and shade everything to the right, would shade this positive section of the number line. And everything that is less than -5, we would do an open point there, and we would shade left further into that negative section of the number line. And since we're just taking the union of them, all of that is just part of the solution set. So there's no overlap, but there doesn't have to be an overlap when we're dealing with or compound inequalities. So this is the graphical solution. In interval notation, we would read this from left to right. We would say we would start at negative infinity and go up to negative 5. Then we would start back at 1 and go to positive infinity. So as intervals, we would see that would be negative infinity, comma, negative 5, use a curved bracket, union with 1 with a curved bracket because 1 is not included, up to positive infinity. Okay, this is our last example for this first set of notes on solving absolute value inequalities, and you'll see that this time we do not have the absolute value bars isolated. So step 1, isolate those bars by subtracting a 2 on both sides. So that leaves me with absolute value of 2x plus 4 is greater than or equal to 6. Once the bars are isolated, now I can create two problems. And since it's a greater than symbol, I'm going to use the word or. So my two problems would be 2x plus 4 greater than or equal to 6, or, because that was a greater than symbol, 2x plus 4, flip the symbol, less than or equal to, change the sign after, negative 6. So here's the two problems. Go ahead and pause now and please solve these two problems. Okay, and now all of you who did not pause and who are just waiting for my answers to pop up, I know you're doing that and you are in trouble for that. So you can rewind now and then pause and work it out on your own and then push play and look at my answers. Okay, so now that we've settled that and I'll let you know that I know what you're doing, let's take a look at our solution set. Let's graph the solution on a number line. So it's an or problem. We know it could look like glasses, or it could look like the entire number line being shaded, or it could shade in one direction. Let's see. The numbers we care about seeing here are positive 2 and negative 5. This says x includes all the numbers that are greater than or equal to 2. So I'm going to put a closed point there and shade right. And all the numbers that are less than or equal to negative 5. So closed point and shade left. So this one looks like glasses again. It's supposed to be a closed point there. I can't close my point in. There it is. Okay. And now let's write the intervals. We start at negative infinity and we go all the way up to negative 5. But this time, negative 5 is included. So use a square bracket there. And then we're going to union that with, and I'm going to have to write it under because I'm running out of space, square bracket because we include 2, and we go up to positive infinity. So these are some examples of how we solve and graph absolute value inequalities. Hopefully, I've led you up to being able to be successful with this. We started with absolute value equations, then we did compound inequalities, and these absolute value inequalities really use everything that we've learned on that. So hopefully you followed okay and you filled out your guided notes. Bring it to class to get a grade, and we'll take a look at some more of this together tomorrow. Thanks. Bye.